Hi everyone and welcome to this brand new web scraping crash course with Python using Request and LXML. And I just want to let you know this 1 hour video is only a demo of my new web scraping course on Udemy. So if you enjoyed the content and wanted to learn more, please use the link in the description box in which I included a coupon code with the maximum discounted price I can offer to the first 50 students who purchase the course. Also, if you like the content, please help me with a like, share and subscribe with your friends. Hi everyone, in this video I'm gonna try to show you briefly some different tools and frameworks used to do web scraping. Alright, so in overall there are plenty of tools you can use nowadays to do web scraping. And by saying tools I mean either fully fledged frameworks like Scrapy for example, which is the most popular one and it's my favorite when it comes to large and complex projects. By the way, I already have a course about it. If you wanna check it out, you can check the bonus section I'm gonna add at the end of this course. Now, in alternative to frameworks, we have modules. Two of them are widely used. The first one is called Beautiful Soup, and the second one is called LXML. Basically, these two are called parsers. We use them to parse HTML web pages. In this course, we'll be using LXML because it's much more lighter and faster. Don't get me wrong, I'm not saying LXML is better than Beautiful Soup or Beautiful Soup is better than LXML, not at all. However, Beautiful Soup is richer in terms of functionalities. It has more functions to use, but since in web scraping we use what we call XPath and CSS selectors to select what piece of information we want to scrape, means we really don't need such a complex tool to perform simple tasks. Of course, we're gonna cover XPath and CSS selectors in details, so no worries about that. And one another advantage of Beautiful Soup is it handles very well broken HTML web pages unlike LXML. This is why in this course I'm gonna show you later how to combine something called a soup parser used by Beautiful Soup with LXML to parse broken HTML web pages. All of that with one single line of code. Now in combination to LXML, we're gonna use also a well-known package in Python called requests. And basically this package is used to send a request to a particular website to get the HTML markup or HTML response in return. So to summarize, we're gonna use LXML with requests. Requests, we use it to download the HTML markup, and with LXML, we can pass that HTML markup to scrape the data we want. Of course, all of that, as I said before, using CSS selectors and XPath. Now, more importantly, and what I'm really excited about is Splash. Splash is really a powerful HTTP API. It's like a browser, but the way we communicate with that browser is through some commands. So there is no graphical user interface to interact with. We use Splash to handle websites that do rely on JavaScript to render the content. Because as you may already know, requests itself can't handle JavaScript. This is a common problem in web scraping, and I know this might sound blurry to you, but as we go through the course, you will get the idea. And of course, I'm gonna explain why requests itself can't handle websites made purely with JavaScript. I can't find really much tutorials about Splash on the web. I don't know why, because for me, it's a wonderful, brilliant, and powerful tool to use. However, people always stick with simple ideas and are afraid of using new tools. But in alternative to Splash, there is also something called Selenium, which automates a browser too. It's what most people use, even though Selenium wasn't created to do web scraping. I don't know who came up with this idea, I really don't know, because it's slow as heck when it comes to scraping large websites. For small projects, we can tolerate the performance, but for large projects, although it's not an efficient solution to use. So this was briefly the tools we use to do web scraping. There are some extensions for browsers and some free and paid online services. Of course, we are not going to use them since the aim of this course is to teach you how to get the job done without relying on tools created by someone else. So that's pretty much everything. I tried to summarize as much as I can. In the next video, we're gonna set up our development environment from scratch using the latest technologies. Alright everyone, so to follow along with this course, you should have Python installed on your computer, and the latest version at the time recording this video is 3.7.3. That's what I'm gonna be using. Chances in the future you're gonna see a higher version. That's perfectly fine. You can use it, of course. However, if you already have, for example, Python version 3.6 installed on your computer, I recommend you to uninstall it and install version 3.7. Once you've downloaded it, just open up the executable, check add Python 3.7 to path, and then click on install now. That's all what you need to do. Alright, now in order for you to confirm that Python was installed correctly, just open up the command prompt and launch the command python space hyphen. This should output the version. If it wasn't outputted or you got a different version, means you haven't installed correctly. Next, what we need is a code editing software to write code, right? Some people prefer to use Sublime Text, Atom, and some other code editing softwares. What I'm gonna be using in this course is this amazing code editing software called Visual Studio Code. So head over to code.visualstudio.com. It's really fast. It has some handy extensions we're gonna use along with this course to increase our productivity, and it's cross-platform. Means you can install it under different operating systems. So go ahead, grab the installer and install it on your machine. Once you've done that, just create a new folder on your desktop or whatever you want called projects, and then right click on that folder and then choose open with code. This will fire up VS Code with the projects folder. Open it. Now for macOS users, chances you don't have the option open with code. So what you can do is launch VS Code manually and then click on file and then open folder, choose the projects folder and then click on select folder. Alright, now we're gonna install an extension called Python in VS Code. So click on this extensions icon and then search for Python. Open up the first one and make sure it belongs to Microsoft, and then you're gonna see the install button. Just click on it and then reload VS Code. Now the next step is we need to create a virtual environment to store all the packages we're gonna use in this course. We can use Python VM, for example, to do that, or the virtual environment package. However, I'm gonna show you the latest way of creating virtual environments in Python. So let's go to View and then Terminal. Notice the shortcut is Ctrl+U with accent. That's the shortcut I have to open the terminal, and that's what I'm gonna be using next time. So let's click Terminal and let's install a package called pipenv. So pip install pipenv. Press enter. Once pipenv is installed, we can create a virtual environment by using the command pipenv space shell. This will take some time, so I'm gonna fast forward the video a little bit. Alright, we've successfully created the virtual environment. Now on your project explorer, you should see a pip file which looks like this. We have the dev packages section, and we have the production packages section, and we have the Python version we are using. Now as a development package, we're gonna use pylint and autopip8. Pylint is for error highlighting, it's really useful, and autopip8 is used to follow the pip8 standard in Python. So on the terminal, let's do pipenv install pylint space auto pip8 and then -- dev, because as I said, these two are only for development purposes. Alright, beautiful. Notice that pylint and autopip8 are now listed under the development packages. Now, more importantly, we're gonna use LXML to parse HTML web pages, right? And as a start, we'll be dealing with some HTML files created by me in order to get you up and running with the fundamentals. So let's go ahead and install LXML, pipenv install LXML. This will install LXML under the production packages because we haven't used the -- dev option. Alright, perfect. Now once everything is set up, let's go ahead and create a new folder called fundamentals. And inside that folder, let's create a new file called app.py. This is where we're gonna experiment with LXML. Now notice when we opened this app.py file, a new folder called .vscode has been listed up in the project explorer, which contains a file called settings.json. This one is created automatically by VS Code. All it does contain is the path to our virtual environment. Currently, pipenv did create a virtual environment under my C drive, the users folder, and then my username, and then the .virtualenvs folder. And notice pipenv did name the virtual environment projects plus a random number. And that's what I like about pipenv is the ability to automatically create and generate virtual environments, plus the ability to separate between dev packages and production packages. Alright, so this was everything for this video. In the next section, we're gonna start learning about LXML. Alright everyone, so what we're gonna do in this section is we're gonna experiment a little bit with LXML core fundamentals. And for that purpose, you will find as a downloadable resource for this video a zip file which contains one folder called src with one HTML file inside it. So go ahead, download the zip file I included, extract it, and then paste everything inside the fundamentals folder. Now, this HTML file is basically an HTML web page, and as you can see, it does contain one paragraph tag, one UL tag or element, which stands for an ordered list, and within that UL element, we do have two list items. The second one does contain an anchor tag, which is basically a link. Of course, if you don't know HTML, that's not a big problem, but I just want to let you know that a website is made up of some tags or elements like we have in this file. Now, if you want to preview this HTML file, you can go ahead and open up the extensions tab and search for an extension called live server. Open up the first one and then install it. Once you've installed it, go back to the HTML file, right click on it, and then choose open with live server. This will fire up a lightweight server under this address 127.0.0.1 with port 5500 and renders the HTML file for you, okay? So here is how the HTML file looks like within a browser. I know it feels so boring, but as you may already know, I just want to give you a gentle introduction to LXML. Therefore, I had to create something simple to not confuse you. And for your record, later on, we're gonna start with real-world websites. Now back to VS Code. Let's stop the server by clicking here. Beautiful. Now I'm gonna open the app.py file and the HTML file I told you to download side by side. So let's bring this here like this. Beautiful. Alright, now within our app.py file, what we're gonna do is tell LXML to open this HTML file so we can parse it, okay? So on the top, we need to import a module called href. So from LXML import href. Now the href module has a method called parse. So let's call it out href.parse. Parse takes as an argument the source, the parser, and the base URL. These two are not required. As you can see, they are both set to none, whereas the source parameter or argument, which basically can be a file object or a path to the target HTML file, is required. So currently our HTML file is within the fundamentals folder, and within this fundamentals folder we have the source and then we have the HTML file. So inside the parse method and as a string, we set the source to fundamentals /src /web_page.html. Now the return type of the parse method will be an element tree object. Let me show you. So let's store everything in a variable called tree, and then let's print tree. Control S to save the file. Now let's execute the file. You can go to view and then terminal, or you can use the shortcut Ctrl+U with accent. So I'm going to use the shortcut Ctrl+U with accent. And if you don't see the virtual environment between two parentheses, all you have to do is to close or kill the current terminal and then redo the same steps. Now let's execute the file, Python fundamentals app.py, press enter. Okay, so we got lxml.href.underline element tree object. Now in your mind, why they called it element tree and not, for example, HTML object or anything else? Well, simply because the parse method will indeed take this HTML file and convert it to a tree. So in our point of view, an HTML file is just an HTML file with some tags inside it. That's how we see it. But to LXML, an HTML file is treated as a tree of elements. Let me show you. So when we call the parse method, this HTML file will be converted to something like this. So we have a tree-like structure that has all the HTML tags converted to element objects. So we have the HTML element object, which has an attribute called lang for language, which is treated as a child of that HTML element. And in addition to that, this HTML element object has the head and body as direct children too. Now, the head element object contains the title element object as a child. With that being said, the title element object does also have the text "This is the title" as a child too. Next, the body element does have as children the paragraph element object and the UL element object and so on. Now, the reason why they used a tree-like data structure and not some other data structures like arrays, for example, and linked lists is because the tree data structure is mainly used to store information that naturally forms a hierarchy like the parent-child relationship. Now, alternatively, if you do want to output what's inside the elementary object, we can call a tree.toString and then we pass the tree as an argument. Control S to save the file and let's execute it again. Beautiful. As you can see, what we get back is the same HTML markup contained in our HTML file. Now, before I'm gonna end up this video, I'm gonna show you some tricks regarding VS Code. So each time we want to execute our script, we have to save the file, open the terminal, and then launch the command python fundamentals app.py. This is too much time consuming, so to increase our productivity and summarize all these steps in one keyboard shortcut, we will be using an amazing extension called Code Runner. So within the extensions tab, search for Code Runner, open up the first one and then install it. Once you've installed it, press Ctrl+Shift+P to open the command palette and then search for or type in open user settings. And then click on this curly braces. Beautiful. I'm gonna close the HTML file. Now, what we need to do is configure Code Runner to work with the virtual environment we created using pipenv. For that being said, copy and paste the 3 commands I'm gonna add as a downloadable resource to this lecture. So this first one will basically tell Code Runner to execute the current Python file using the Python executable from the virtual environment we generated using pipenv and add the file name to it. Now, this second command will basically clear the output each time we execute the file. And the last one will basically tell Code Runner to automatically save the file before executing it. The rest is some configuration I use with VS Code. We have the font size, the zoom level, and so on. So make sure to paste all the 3 commands and then Ctrl S to save the file. Now let's go back to the app.py file, and to execute it, we can click on this icon here, or we can press Ctrl-Alt-N. Here is the output we get back. Alternatively, to hide this output window, we can press Ctrl-J. So this was everything I wanted to teach you in this video. In the next one, we will see how we can extract what's inside the elements, all of that from the element tree object of our HTML web page. Alright everyone, so let's say this time we want to extract, or in other words, scrape the title from our HTML web page. So how can we do that? Well, because now we do have an element tree object, means we have a couple of methods that are exposed to us. For example, to select the title from our HTML web page, we can call our tree object and then we use the find method. Now the find method takes as an argument the path to the element or the tag we want to select. So in our HTML markup, we know that the title is inside the head tag. So in the find method, we type as a string the path to the title. So head/title. This expression will return an element object of type title. So let's store everything in a variable called title and align element. And let's print title underline element, Control Alt and to execute, and voila, we got an element object of type title. Now, if we do want to print the actual title value, we can call the text property against the title element. Let's execute again, and voila, we got this is the title. Now let me ask you a question. Why in the path in which I specified in the find method, I didn't start from the HTML tag? Instead, I started from the head tag to get the title. Because we can clearly see here that the title tag is inside the head tag and the head tag is inside the HTML tag. Well, we can't start from the HTML tag. Instead, we always have to start from one of its direct children. For example, if you want to select this paragraph tag, we have to start from the body because the body is a direct child to the HTML tag. Now, as a challenge, I wanted to select this paragraph tag using the find method and output the text hello world. You have 10 seconds, so be quick. Alright, so to select the paragraph tag, we call tree.find and we specify the path to that paragraph tag, which happened to be body/p. Let's store everything in a variable called paragraph element, and let's print out paragraph element dot text. Let's execute the file, and we do indeed get hello world. Now, in alternative to the find method, we have another one called find all, which by its name we can understand it will find all the matching tags and return them as a list of element objects. For example, to select all the list items that are inside this UL element, we have to use the find all method, because if we do use the find method, we will end up getting only this first list item. So let's create a variable called list underline items equals to tree.findAll, and inside it we specify the path to our list items. So we start from the body and then UL down to the li tags. Now let's print list underline items, and as you can see, we got a list of 2 element objects of type li. Now, because we do have a list, means we can iterate through each element object to extract the text value. So for li in list underline items, print li.text. Let's execute the file, and notice for the first list item, we got the full text value. However, for the second list item, we only get created by. So if we take a look to our HTML file, we can see that the second list item does indeed have another a tag with my name inside it. And the reason why we didn't get the full text value is because in our find all method, we made it clear to LXML we only want to get all the list items. We don't care if there is an a tag inside it or anything else. So one quick fix we can apply is inside the for loop, we can create a variable called a equals to li.find. Notice this time I'm using the li element object and not the tree element object. And then inside the find method, we only want to get the a element. So if there is an anchor tag inside this li, the a variable value will be an element object of type a, else a will be set to none. So based on this logic, we can write a basic if statement. If a is not none, means there is an a inside the list item, we print. I'm going to use Python 3 string formatting, which you have to be familiar with. So let's start with f, double quotes, 2 curly braces, li.text, concatenated by 2 curly braces, a.text. Else means if there isn't an a tag inside the list item, we only print li.text. Let's execute the file, and voila, this time we got created by and then my name. Notice that between created by and my name there is an extra white space and a new line. This is happened because in our HTML markup we have this new line here and we have this empty white space. So to remove this and clear the output, we can call the strip method against the text property of the li element object. Let's execute the file, and voila, this time the output looks much cleaner. Now, one of the downsides of LXML is that it's not rich in terms of the methods that are exposed to us through the elementary object. And one thing I hate about it is that every time we want to select a tag from the HTML markup, we have to specify the absolute path tag by tag. For example, to select all the list items, we knew that we have to start from the body and then UL down to li. This was easy, right? However, what if you were dealing with a more complicated HTML web page with thousands and thousands of tags? In this scenario, this approach won't be a good choice. So in the next video, I'm gonna show you a better approach which you can use when dealing with large or more complicated HTML web pages. Alright everyone, so in this video I'm gonna show you another way of selecting tags or elements from HTML web pages, and this time we're gonna use XPath. I know most of you have never heard of XPath before, but think of it as a more efficient and flexible way to select tags and extract data from HTML web pages. So right now in this video I'm gonna give you a brief introduction to XPath, and in the next section I'm gonna cover it in detail. So if you don't understand everything I'm gonna explain in the next couple of minutes, don't panic, okay? Because everything will become clear to you in the next section. So to select tags using XPath in LXML, we can replace the find method by XPath. Now the XPath method takes as an argument the path to the target tag, just like the find method. But what's more special about it is we don't need to specify the full path tag by tag like in the find method. So to select the title, we only need to write /title, and that's it. Now, if we execute our code like this, we're gonna get an attribute error. List object has no attribute text. And that's because the XPath method kind of works like the find all method. It always returns a list, even though we do know that in our HTML markup, we only have one title tag. So in order for us to access the text property, we need to access the first item on the list returned by the XPath method. So 2 square brackets and then 0. Let's execute again, and this time we get the text. This is the title. Now, if you want to get the text using XPath instead of accessing it using the text property, which is related to LXML, we can call a function inside the XPath method called text. So slash text with 2 parentheses. Of course, by doing this, we no longer need this text property, so let's delete it. Let's execute again, and we're gonna get the same thing. This is the title. Now, as a challenge, go ahead and select the paragraph tag, this one, using XPath, and make sure you get the text using the text function in XPath instead of using the text property. You have almost 10 seconds, so be quick. Alright, so to select the paragraph tag using XPath, we're gonna replace the find method by XPath and body/p by /p/text square brackets 0. Let's delete the text property. Let's execute again, and voila, we still get the same output, hello world. Now, last but not least, let's rebuild this part of our code using XPath. So I'm gonna delete everything that's inside the for loop so we don't get confused, and let's replace find all by XPath. And to get all the LIs, we only need to change this absolute path to /li, as easy as that. Now inside the for loop, let's print h3.toString li. Let's execute the code, and here is what we get. We got two list items, this one and this one and this one. But notice, since we didn't use the text function, we got the full HTML markup of the two list items. Now, in order to get the text that's inside the two list items, let's create a variable inside the for loop called text equals to. We can output the text either by using the text property or by executing another XPath expression against this element object of type li returned on each iteration. So text equals to li.xpath /text. Now let's print text and let's execute the code. Beautiful. So as expected, we got two lists because we do have two list items. That's obvious. But as unexpected, we got the text of all the tags that are within our HTML code. We have, this is the title from the title tag. We have hello world from the paragraph tag. We have the complete web scraping course from the first li, and we have created by and then my name from the second li. And that's weird, right? Because even though we are executing this XPath expression against the li element object returned by this list items on each iteration, we still get the text of all the tags in our HTML code. So how can we fix this? Well, all we need to do is to add a period at the beginning of this XPath expression, and that's it. Let's execute again. And voila, this time we only get the text of the two li's only. Now, as a general rule, whenever you execute XPath against an element object, like in this case, and not against an element tree object, make sure to add the period at the beginning. Whereas if you execute XPath against an element tree object, like in this case, you don't have to add the period, okay? So for instance, we do have two lists, right? The first one only contains one item with some text, and the second one does contain three items created by my name, \n, and some white space. Now what I want to do is to get rid of this extra white space and the \n characters. And because we do have lists, we can use a method called map. So let's call map here. Now map takes as a first argument a function that will be mapped on each item on the list. So we're gonna use str.strip without parentheses, which will remove all the white space and the \n characters. And as a second argument, it takes an iterable, which is the list returned by li.xpath. So let's cut this part and let's paste it within the map method as a second argument. Now to see the output, we have to convert this text variable into a list. So let's call the list function. Beautiful, like this. Let's execute the file. And voila, the output looks much more cleaner. Now, secondly, I don't want to return a list. Instead, I want to return each item on the list as a string. For that, we can use another function called join, but the problem is the join function must be called against a string. So what we can do is add an empty string here and then call the join function. Let's add closing parentheses here. So basically this will take each item on the list and join it by this empty string. Now let's remove the list function since the join method will return a string. Beautiful, like this. Let's execute the file again. So we got an error. Let me check. Because of this A with accent here. So let's delete it. And let's add a closing parentheses. Now let's execute again. Beautiful. The output is much more readable. Now, beside the XPath method, we do have also what we call CSS selectors to select tags from HTML web pages. So in the next video, I'm going to give you a brief introduction to CSS selectors. And of course, I'm going to add a dedicated section to teach you CSS selectors just like XPath. Choosing between XPath and CSS selectors is a question of preference. I personally always use XPath, but with Splash, which I'm going to cover in this course too, using CSS selectors is required, and that's the reason why I decided to include it. Otherwise, I wouldn't at all. Alright everyone, so this time we're gonna learn about XPath. And one thing I wanna tell you before we start is for every project we're gonna do next, I'm gonna use XPath over CSS selectors. The only reason why I showed you how to write CSS selectors is because we're gonna need them when I'm gonna cover Splash. And of course, for each project, I'm gonna add an article showing you the CSS version of the code I write. Now for this video, we're gonna use this website to test every XPath expression we're gonna write. And later on, when we start with real websites, we'll use Google Chrome. So the first thing you have to do is to download this HTML file I included to this lecture as a downloadable resource. I only made some tiny changes so I can show you what XPath can do. After that, copy everything from that HTML file, open up your favorite browser and navigate to this website, and then paste everything in this text area. Now, in the previous section, we learned that we can select an element from the HTML web page by using double slash and then the target element name. So let's say we want this h1. So to select it, we use double slash h1. So this XPath expression will look for all the h1 elements in our HTML markup without taking into consideration the element position, whether it's inside another element or outside it. However, as I said to you in the previous video, we always tend to be specific about element selection. So let's say we only want to get the P's that are inside this div element with the class attribute set to intro. Now in XPath, if you want to select any element based on its class name, we start with double slash as usual, the element name, which is div in our case, and to specify the target attribute, whether it's a class ID or anything else, we use double square brackets, @ class equals to intro. So like this, we selected only the div with the class attribute set to intro. And if we want to get the P elements that are inside that div, we add /P. So looking at the syntax, I know CSS looks much cleaner than XPath, but XPath is richer in terms of functionalities. So in addition to selecting all the divs with the class intro, we want also to select this div with the class attribute set to outro too. For that purpose, what we can do is use the OR logical operator inside the square brackets. So OR @ class equals to outro. So this XPath expression will be evaluated like this. Select all the P elements that are children of this div element with the class attribute set to intro or with the class attribute set to outro. And unlike CSS selectors, XPath did indeed select this span with ID set to location, because if you remember, in CSS selectors, we have to explicitly add the span in order to select it. Now, if we want to only get the text value of the selected elements, we add /text, as easy as that. Now, let's say we want the href attribute value from these two A elements. So what we can do is write /A and then /@href to select the href attribute only. But what if we want to only select the A that its href attribute starts with HTTPS and not HTTP? So let's delete this part and let's add the square brackets. Now in XPath we have a function called starts-with. This function takes two arguments. The first one is where you want to search. In our case, we want to look in the href attribute value, so @href. And the second argument is the value you are looking for, which is in our case HTTPS. We got an error, that's because I forget to add the S here, so starts with. There we go, this time we only get the first A element. Alternatively, if you want to select only the A elements that ends with FR, we can replace starts with by and -with. Let's change the value to FR. There we go. Now we got the second link. However, the ends with function is supported only in XPath version 2.0, and XML does only support version 1.0. Actually, not only XML, even browsers like Chrome do only support version 1.0. So if you try to use this function, you will end up getting an error. I'm not gonna cover how to solve this in this video yet because things can be a little bit complicated. Now, besides this starts with function and the ends with function, we can also search for text in between. Means not on the start nor at the end by using the contains function. So let's replace ends with by contains. This function also takes two arguments. The first one is where we want to look. So let's say we are looking for a elements that the href attribute contains the word Google. Now, something I want to make you aware of is sometimes we also want to look for the text that the element does contain. For example, let's say we want to select the A element which contains the text France. So, for that purpose, instead of passing the attribute name as a first argument, we use the text function. And let's change the value to France with capital F. One important thing is that the contains function starts with and ends with the value you pass as a second argument is case sensitive. Means if I make this f lowercase, we won't get anything in return. Okay, so let's revert back this to capital F. There we go. Alright, now let's talk a little bit on how to select elements based on their position. And let's say we are interested in getting this first list item from this UL element. So let's change our XPath expression to /UL with ID equals to items and then /li. Now this XPath expression, of course, it will return all the list items that are inside the UL element. And to select the first list item, we use square brackets and then 1. Like this, we only get the first list item. Now to select both the first one and the last one, which is on the 4th position, maybe you can think of using the OR logical operator. So let's add OR here and then 4. However, like this, we do get all the list items, not just the first and the last one. So alternatively, we have to use another function called position. So let's delete all of this. And let's set position, it's a function, so we have to use the parentheses equals to 1 or position equals to 4. We got an error, that's because I forgot to add the square brackets here, so let me add it. Beautiful. So like this, we do indeed get the first and the last item. Now, since we are interested on getting the last item, we can replace 4 by another function called last. This way we don't have to manually count on which position the last item is. And one cool thing I want to show you is we can even use mathematical operators like greater than and less than. For example, if you replace this equal sign by greater than, and we delete this part, we will get all the items where the position is indeed greater than 1. So this was everything for this video. As always, don't watch it once, repeat and practice until everything stays in your head. In the next video, I'm gonna show you how to navigate in the HTML markup of the tree using XPath. Means I'm gonna show you how to go up and go down in the HTML tree, which is something CSS selectors lacks of. Alright, here is the web page we are going to scrape. It's for a book called A Light in the Attic, and first we will see how to send a request to this URL using Python so we can download the HTML markup, and later on we will extract all the useful information about this book. One thing I want to show you is the HTML markup of this web page can be viewed by pressing the shortcut Ctrl+U or by adding view -source: at the beginning of the website URL. So in our code, what we're gonna actually do is download the same HTML markup using Python so we can parse it using LXML. Now to send a request using Python, we will use a package called Requests. And the latest version at the time recording this video is version 2.21.0. So back to VS Code, make sure to create a new folder called project_1 and inside it create an empty app.py file. So let's open the terminal and let's do pipenv install requests. After that, within the app.py file, let's import requests. Now, since we are only interested in getting the HTML markup, we will use a get request. So let's call requests.get. Now, get takes two arguments. The first one is the target website URL. So let's set URL equals to, and I'm gonna paste the website URL. In addition to that, the get method takes an optional keyword argument as a second argument. We are not going to add it, for instance, since it's optional. Now let's store everything in a variable called resp, and let's print resp. Control Alt N to execute the file, and here's what we get. So we get a response object and then 200. 200 is a response status code. And according to the HTTP protocol specification, 200 means the request was fulfilled successfully. In other words, the server did indeed accept our request and sent us a response in return. In contrast, if we send a request to a web page that doesn't exist, let's add an X here for example, and then let's re-execute the file, and this time we get a response object with a status code set to 404. 404 means the web page was not found, okay? There are a lot of them, and I'm gonna add an external resource to this video so you can check them out. And of course, you don't have to memorize all of them. Let's revert back the changes. So I'm gonna press Ctrl Z, beautiful. Okay, now let me show you how to print out the HTML markup we get back. For that, we call the text property against the response object. Let's execute the file again. And this time we get the HTML markup just like I showed you in Google Chrome. Now, in contrast to the text property, we have also the content property, which does the same as the previous one. So let's change text to content. Let's re-execute the file. And we still get the same response. However, this one returns a byte object. As you can see, we have the B here at the start. So the question is when to use the content property over the text property. Generally speaking, we use the content property over the text property when we want to download, for example, a non-text response like images, videos, PDF documents, and so on. But since we won't be downloading any image from the web page we are going to scrape, we can choose to use the text property over the content property. So let's revert back the changes. Now, in the next video, we will take a look on how a request sent from a Python script differ from a request sent from a real browser. Alright, now we have the HTML markup of the website we are going to scrape, means we are one step away from starting to build the script that we scrape or extract the data we want. So from this book page, what I want to extract is the book title, the price, how much is left in the stock, and the product description. Now, in order for us to write every XPath expression, we need to see where does this book title, for example, is in the HTML markup, okay? So from the developer tools, select the elements tab and then click on this inspection tool. Now, this inspection tool is like your right hand in web scraping. It's really helpful, and as we hover over the elements on this web page, it shows us where it does fit in the HTML markup. So let's click on the title. And here it is highlighted in blue. So it's an h1 tag within a div with two classes called sm6 and product main. Now previously I told you we can test XPath expressions within Chrome, right? So to do that, press Ctrl F and a search box will appear at the bottom, which allows us to search for any data using a text, a CSS selector, or XPath. Okay, now first what I want to do is select this div, which does contain mostly all the data we want to scrape. So right in the search box, we can do /div square brackets @ class equals to product and the line main. However, like this, it won't return anything, simply because we do have two classes in our div. So alternatively, we can wrap everything in the contains function. So let me add contains here. Let's add the closing parentheses. And let's replace the equal sign by a comma. There we go. Now from that div, we can select this h1. So slash h1, then slash text to select the text content. Notice how Chrome highlights the element being selected in yellow, which is cool by the way. Now to select the book price, which is this first p element, we can either target it by its class attribute or by its position within this div. So let's replace h1 by p square brackets 1. Beautiful, we got the price. Next, to select how many books left in the stock, which is this second p, we can change the position from 1 to 2. Now notice how many elements this XPath expression did return. We have 2 elements. But wait a second, normally we should have 1, right? And as you notice, the first element is empty, and the second one contains how many books available in the stock. And the reason why this happened is because of the line break after this p element. Now, as a challenge, I want to select the product description using XPath. You have 10 seconds, so be quick. Alright, welcome back. So first, let's click on the inspection tool and let's select the product description. There we go. It's a p element without any ID or any class. So let's try /p. And this will get us all the p elements. So we have 1, 2, 3, 4, and the last one is our target p. So let's add square brackets and then 4. But unfortunately, you will be disappointed if you follow this way, because as you already see, we have 0 elements in return. So what will be a better approach to solve this issue? Let me show you. So I'm gonna delete the square brackets 4. And let's go to the last p element. Now have you noticed that this div with ID set to product description and this p element are siblings, because they do belong to the same parent, which is this article element. Let me collapse this div so we can see it. Let's recap. So this p, which is the description, and this p with ID set to product and the line description are siblings because they share the same parent, which is this article element. So what we can do is select the div with ID set to product description, and then we use the following sibling axis. So /div with ID equals to product and the line description, and then slash following hyphen sibling colon p. And of course we want to get the text, so slash text. See, now we have the product description nice and clean. Alright, so these are all the XPath expressions we need. In the next video we will implement them in LXML, so make sure to redo them all. Alright, now we have all the XPath expressions we need, so let's build the actual script which will scrape the data. So first we need to take this response object and convert it to an elementary object. So we can apply XPath or CSS selectors, and if you remember, previously we used to import the eTree module from LXML and we used the parse method to get the job done. However, now the response is of type text rather than an HTML file. For that, instead of using the eTree module, we're gonna use HTML, and everything else I showed you previously when I talked about eTree remains the same. So let's do from LXML import HTML. Then down here, I'm gonna delete everything. And let's create a variable called tree equals to HTML.fromString. Now fromString takes an argument called HTML. So HTML equals to rasp.text. There we go. Now we have an elementary object, means we can apply XPath. So let's create a variable called title equals to tree.xpath, and I'm gonna paste the XPath expression that will select the book title text. And as we learned before, since we are returning one element, we use square brackets with index 0. Let's print title and let's execute the file. There we go, it's outputting the book title. Now I'm gonna show you a trick in VS Code that will save you a lot of time. And what I wanna do is duplicate this line 3 more times. So to do that, you press Alt Shift row down 3 times. 1, 2, 3. Let's set the second variable to price. And instead of selecting the H1, we want P with position set to 1. Next, let's change this to availability. And instead of selecting the H12, we want the P with position set to 2. And let's remove the square brackets with index 0 so I can show you the output. Now let's print price and availability. Let's execute the file. Alright, look at the output. The price is okay, however look at the availability. We have a list, that's what I expected because we removed the square brackets, and on this list we have 2 items. The first one is empty, and the second one does contain how much we have in stock. And if you remember previously, when we tested this XPath expression in Chrome, we did indeed get 2 elements in return. So it's the same here. And because the data is on the second index, we have to use square brackets with index 1. So let's add square brackets with index 1. Now let's execute the file again. And voila, we get how much we have in stock. But notice we have some white space here. So to remove it, we can call the strip method. So dot strip. Let's re-execute again. And voila, the output is cleaner now. Now finally, let's change this variable to description. Back to Chrome. Let's copy this XPath expression. Back to VS Code. Let's delete this one. And let's paste the new one. Alright, now let's print description. Let's execute the file. There we go, we have the book description. Now, one last thing, I want to output everything using a Python dict, okay? So let's create a variable called book underline information equals to double curly braces. The first key, I'll call it title equals to title. The second one is price equals to price. The third one is in stock equals to availability. And the last one will be description equals to description. Now let's print book underline information. Let's execute the file. There we go. Now we have all the info related to one book stored in one variable. Now, of course, our script does work perfectly fine because we do get the data we want, right? However, I'm here to show you how to write better code too. So have you noticed it in all these 3 variables, we have this part of our XPath expression repeated in all of them. That's not a good practice. Instead, what we're gonna do to avoid repeating things is create a variable called product underline main equals to tree.xpath. I'm gonna copy this part of our XPath expression and I'm gonna paste it here. Now product underline main will be an element object, right? This means we can apply any XPath expression against it too. So here, here, and here, instead of using the tree variable, we're gonna use product underline main. So I'm gonna put my cursor here, Control D 3 times to select all of them, and let's replace them by product underline main. Now I'm gonna press escape. Now the next step is to select this part of our XPath expression and then Control D 2 times, and let's replace it by period and then forward slash. Now let's re-execute again. There we go, we got an attribute error. List object has no attribute XPath. And that's because we forgot to add square brackets with index 0 here. Now let's re-execute again. There we go, now we get the output. Now in the next video, what we're gonna do is process this in underline stock key to show how much we do have in stock instead of outputting the full text in stock 22 available. Okay, now as I told you, we're gonna modify the output of the availability variable to output only how much we have in stock. By the way, I misspelled availability, so instead of I should add A. Let's do the same here. Beautiful. So there are plenty of ways to clean the data, and there is no universal rule we can apply. In fact, this depends on how much you are experienced in programming though. For this video, I'm gonna show you two ways. So the first way is by using a regular expression, aka regex. And if you don't know what regex is, it's like some filter or a condition called a pattern we apply against a string, for example, or a piece of data, so we can extract a substring from it. Now what I'm gonna show you is a website called regex 101. It's very useful when it comes to testing regular expressions. So on the left hand side we have different flavors, aka programming languages. So let's choose Python, and here we have one input box. This is where we're gonna type the regular expression, and in this text area we write down the string we are testing against it. So back to the book detail page, let's copy this part back here and let's paste the string. Now, more importantly, let's write one regular expression that will select only 22 from this string. And notice 22 is the only digit or number available in this string, right? So the idea is to write a regular expression that will only select digits. For that, we use \d+. \d means we want to select a digit, and the plus sign is to look for all the digits in our string. And as you see here, we get 22 as an output. Alright, now we have the regular expression, so back to VS Code, and let's import a module called RE, aka regex or regular expression. Now down here under availability, let's create a variable called in_stock equals to re.compile. Now compile takes as an argument your regular expression. You start by R to specify that we are using a regular expression, then two quotes, and then \d+. After that we call the findAll method, and as an argument we pass the availability string. By the way, the findAll method in this case is related to the RE module and not to LXML, so please be aware of that, okay? Now instead of using the availability variable here, let's call in stock. Let's execute the code. There we go, we have 22 as a list. So to remove the list, we can use square brackets 0. Let's execute again. Perfect, we have 22 as a string. Now the second way I'm gonna show you to get the same thing is purely related to Python. So what we have to do first is to create a function that takes a character as an argument. I'm saying a character and not a full string, and check if that character is a digit. So on the top, let's define a function called get_digit, which takes x as an argument. Then we're gonna check if x.isDigit, we return x. This is what I love about Python. It's like a plain English, right? Now down here, let's delete this part. And we're gonna use a function called filter. Now filter takes as an argument the function you wanna apply. And as a second argument, it takes an iterable something like a list. So let's call get_digit. Notice that we are passing it as a reference without parentheses. And let's call the availability string. By the way, strings in Python are iterables too. So this will return a filter object. This is why we need to wrap everything in another function called list. So back here, and let's call list. Beautiful. Let's execute again. So we got a list with 2 and 2 separately. So what we're gonna do is join these two numbers. For that we use an empty string, and then we call the join function like this. Let's execute again, and voila, we get 22. Now finally, the get_digit function does only one thing, right? So as an alternative and more advanced way, we can delete it And down here, instead of calling getDigit, what we can do is use a lambda function, aka anonymous function. So let's call lambda x colon x dot is digit. I'm gonna add the t. Basically, this first x is the argument we pass to the getDigit function, and isDigit is the condition we used previously. Okay, now let's execute again. We got name error. Name isDigit is not defined. That's because I add the I here. So I'm gonna remove the I. Beautiful. Now I'm gonna execute again. And voila, we still have the same output, 22. It's really up to you whether to use a regular expression or the second way. So this was everything for this video. In the next one, we'll see how to write the book information, whether to a JSON file or to a CSV file. Alright, now we're gonna write two functions. The first one will be responsible for writing the book info into a JSON file, and the second one will be responsible for writing it to a CSV file, aka comma separated values file. So let's start with the easiest one. On the top, let's define a function called write to JSON, which takes two arguments. The first one will be the file name, and the second one is the data we want to write. Now what we're gonna do is create and open a file with Python. So let's define a variable called f equals to open. Open takes the file name as an argument, so file name, and the mode as a second argument. If you want to read a file, you can use the R mode for reading, but since we are going to write into the file, we use the W mode for writing. Next, we call f.write to write into that file, and as an argument, we need to pass the data we want to write as a string. But the problem we have is this book underline information is of type dict. So this data argument later on will be of type dict. This means we need to convert it to a string. For that, let's import a module called JSON, and down here we call json.dumpas. So we can convert that dict to a string, and then we pass the data as an argument. Now finally, let's call f.close to close the file. Let's test everything out. So after printing the book information, let's call write to JSON. The file name will be data.json, for example, and the data I want to write is book underline information. Let's execute the file. Beautiful. Now let's open the project explorer. There we go. We have a new file called data.json. Let's open it, and then let's do Alt-Shift-F to format it. And here's the book information we scraped. Of course, in real world, you would scrape a lot of data. This is your first project. I don't want to make things complicated. Later, when we scrape more data, we will have larger JSON files. And for your record, we call this a Unicode character. It's not a bug, okay, or an error. In fact, it represents the pound money sign. Now back to our app.py file, and let's define a function. So def, and let's call it write to CSV. Now this function takes the same arguments as the write to JSON, so file name and data. Good. Now the difference between JSON and CSV files is that CSV files must have what we call headers. So let's set headers equals to double square brackets to define a list. The first one is title. The second one is price, then in stock, and description. Make sure you follow the same order of the keys defined in the book underline information dict. Next, let's open a file, and this time I'm gonna show you another way. So with open file name, the mode is W, then as F. This F here is the same as this one, okay? Now what we're gonna do is import a module called CSV. So import CSV. Then down here, let's create a variable called writer equals to CSV dot dict writer. The first argument is the file object, which is f in our case, And the second argument is the headers. So let's call headers. We type writer dot write header, and to write the data we call writer dot write row with the data argument passed to that function. Now let's test it. So let's replace write to JSON by write to CSV, and let's change the file name to book.csv. Let's execute the file. Beautiful. Let's open the Project Explorer. There we go. We have a book.csv file. So we have our headers, title, price, in stock, description, and we have our book information. If you have Excel installed in your computer, you can open it with it too. And that's one advantage using CSV files, is that they are compatible with Excel. Now in the next video, we'll turn our script into a command line program. And more importantly, we're gonna give the user the ability to set the book URL, the file name, and the type of the file from the command line. Alright everyone, so as I told you, what I wanna do now is give the user the ability to launch the app using some custom options, okay? And what do I mean by that is I wanna give the user the ability to launch the app using this command, Python project _1 app.py --book URL equals to, so he can specify a book URL, and I want to let him choose the file name by setting file name equals to, let's say, data.json if he wants a JSON file, of course, or data.csv if he wants a CSV file, okay? So for that purpose, we're gonna use a package called Click. So back to Chrome, here is the documentation, and as it says here, Click is a Python package for creating beautiful command line interfaces. It's very easy, and what I like about it is the auto help generation, as I'm gonna show you later, and the fact that we don't have to manually process what the user has put as options. All of that is done by the package itself with less code. Now, looking at this example provided on the documentation, it's straightforward. All we have to do is to wrap everything in a function, and then we use some decorators. We have to use the click.command decorator, and if we want to create an option, we use the click.option decorator. The option in our case will be --book URL. We can set the default value if we want, and we can set the help too. And the second option, of course, will be the file name. So back to VS Code, let's delete this command, and let's do pip-env install click. Beautiful, it's installed. Now on the top, let's import click, and let's create a function down here called scrape. This function will take two arguments, the URL of the book we want to scrape and the file name. Now let me indent everything inside that function. Now, as we saw in the documentation, we have to add @ click.command. Next, we have to add an option, so @ click.option. Let's set it to --book URL. Next, let's set a default value, so default equals to, I'm gonna cut this book URL, and let's set it as a default value. So if the user didn't provide a book URL, we're gonna use this one as the default value, okay? Next, let's set help equals to, please provide a book URL from books to scrape.com. Now let's duplicate this line, Alt-Shift arrow down. Let's change the command to --file name. Let's delete this default value. For the file name, the default value will be, let's say, output.json. And as a help, let's say, please provide a file name, so a file name csv/json. Now the next step is we need to set this URL equals to book URL, which is the argument passed to the scrape function. Now we are left with one issue. So instead of calling write to CSV, we want to detect that automatically according to the extension the user did provide. So if the file name was data.csv, we call write to CSV, and if it was data.json, for example, we call write to JSON. We have two ways to do this. So we can either add an option here so the user can set the type, or we can grab whatever the user did provide as a file name and extract the extension from it. I'm gonna use the second way, so I'm gonna delete this part. Then I'm gonna create a variable called extension equals to file name dot split, and I wanna split it by the period. So if, for example, the user did set the file name to output.csv, we're gonna have a list like this. The first item will be output, which is the file name, and the second item will be CSV. We need the extension, so we're gonna use square brackets with index 1. Next, let's check if extension equals to JSON. We call write to JSON. The first argument is file name, and the second argument is the book information. Else if extension equals to CSV, we call write to CSV, file name as an argument, and book information too. Else, if the user did provide something else, I want to provide him some feedback. So for that purpose, we call click.echo, which does the same thing as print. So let's say the extension you provided is not supported. Please use CSV or JSON. Now, down here outside the function, we need to check if underscore name underscore equals to two quotes underscore main underscore. We call our scrape function without any arguments. Now back to Chrome. Let's go to books2scrape.com and let's choose a book. Let's say this one, for example. I'm gonna copy the URL back to VS Code. Let's save everything before we launch the app. Now I'm gonna open the terminal. So let's say Python project _1 app.py -- book URL equals to, and I'm gonna paste the book URL, and let's set -- file name equals to, let's say book.json. Press enter. Now let's check the project explorer. There we go, we have a new file called book.json. Alt-Shift-F to format everything. And there we go, we have the book information. Now, if we want to see the help, we can do the following. I'm going to clear my terminal first. So we can launch the command python project _1 app.py -- and here's the auto-generated help by Click itself, which is fantastic. So this was everything for this project. I'm gonna leave an assignment under this video, so make sure to check it out.